Good evening and welcome back. In our previous video, we explored the broad concept of uncertainties and how they play a crucial role in scientific measurements. Today, we will focus on a specific type of uncertainty, which is the absolute uncertainty. We shall dive into what they are, how to calculate them, and why they are essential in precisely reporting the data. We need to understand that every measurement has an inherent uncertainty due to limitations in the measuring instruments and the observer's ability to discern the finer details. For instance, even the most precise instruments cannot eliminate all the sources of error. It could be due to calibration, environmental factors, or fundamental limitations of the measurement scale itself. This is why measurements are always accompanied by a degree of uncertainty reflecting the range within which the true value is expected to lie. For example, let's take there is a task of determining the length of a line. Let's consider that this is a line we need to measure. In order to do that, it's quite obvious that we shall place a ruler against this particular line, and the zero of the ruler would start at that particular point. Suppose the ruler has divisions as shown here. We notice that this particular ruler has graduations after every 1 centimeter. So in this particular scenario, we can notice that the length of the line is certainly greater than 6 centimeters but less than 7 centimeters, which means the number 6 is less than x, which is the length of the line, and this length is further less than 7 centimeters. Now, how is it that we can report such a value? As mentioned earlier, there is a range within which this particular value can be reported, which means the length of this particular line can be reported as 6.5 plus or minus 0.5 centimeters. If you notice carefully, the lower limit of this particular reported measurement would be 6.0 centimeters, and the upper limit or the higher limit would be 7.0 centimeters, which is exactly what we notice in this particular scenario. But then what if we have finer graduations on the scale? Say for example, we have a 6.1, 6.2, 6.3 and a 6.4. We can now again clearly notice that the length of the line here, if you zoom it and observe, is certainly greater than 6.3 centimeters but less than 6.4 centimeters. Now, how do we report this value? Well, pretty simple. We would follow the previous case example here. It would be 6.35 plus or minus 0.05 centimeters. Again, if you carefully observe, the lower limit in this case would be 6.30 centimeters and the upper limit would be 6.40 centimeters, which goes on to say that whenever we are reporting a measured value, there is always a specific range in which it needs to be specified. Whenever we report these values or whenever we make measurements, there are always two different types of instruments: analog and digital devices. To express the absolute uncertainty of various measuring instruments, it's essential to understand the difference between analog and digital devices. For analog devices, as just discussed, the absolute uncertainty is typically considered to be half of the smallest scale division or the least count. For example, if a ruler has a least count of 0.1 centimeters, the absolute uncertainty would be 0.05 centimeters. This represents the uncertainty in measurement due to the smallest interval that can be reliably read. Well, that is exactly what we observed in this particular scenario. The one mentioned in blue, the least possible measured value is 1 centimeter. Therefore, the absolute uncertainty is expressed as plus or minus 0.5 centimeters. While on the other hand, with finer graduations, we noticed that the absolute uncertainty is now 0.05 centimeters. On the other hand, when we look at the digital devices, the absolute uncertainty is equivalent to the least count itself. For instance, if I have a digital stopwatch and it has a least count of suppose 0.001 second, then the absolute uncertainty is 0.001 second itself. This reflects the precision limit of the device's digital readout. While we discuss this, we need to understand that the magnitude of the absolute uncertainty provides insights into the precision of the measuring instrument used. For instance, an uncertainty of plus or minus 0.05 centimeters suggests that a standard ruler was employed, whereas an uncertainty of plus or minus 0.005 centimeters indicates the use of a more precise instrument such as a vernier caliper. From a purely mathematical standpoint, the numbers as mentioned here, say 4.3 and 4.30, are equivalent. However, in physics, these values convey different levels of precision. 4.30 in fact implies that the measurement was taken with a more precise instrument, and this allows for greater precision in reporting the data. We also need to further understand that the absolute uncertainty that is reported need not always come from the measuring instrument itself. So stay tuned for our next video, where we will delve into how absolute uncertainty isn't always just from the measuring instrument. Well, we shall explore how variations in the trial values can also contribute to the overall uncertainty in your results. Well, thank you for watching. If you enjoyed this video and found it helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more informative content. Hit the notification bell to stay updated with our latest videos. You also have the contact information displayed here. Thank you and goodbye.